We have a line that passes through the point A having the coordinates 3, 4. Also, this line makes an angle of pi over 6 radians with the positive direction of x-axis. If this line intersects another line, 12x plus 5y plus 10 equals to 0 at the point B, then determine the length of AB. Okay, let's try to understand the problem graphically first. So here we have the line L, which is going to pass through the point A with coordinates 3, 4, and it makes an angle of pi over 6 radians with the positive direction of x-axis. And also we have another line L prime, whose equation is given to us, that's 12x plus 5y plus 10 equals to 0. So this particular line is going to intersect the line L at the point B. Our goal will be to determine the length of the segment AB. Okay, so here to begin with, what we'll do, we're going to consider that x, y, that is the coordinate of the point B. And using this point, we can define the equation of the line L in terms of the distance form. So here we're going to use the distance form of the line such that we have, so here, now considering the point A, since it lies to the right of the point B, so that means the x and the y coordinates of A are going to be greater than the x and the y coordinates of point B. So here what we'll do, we're going to consider A to be greater than B. So that means the distance form of the line is going to become the difference of the x coordinates. So we have 3 minus x divided by cosine of the angle that the line L makes with the x-axis. So that's pi over 6. So we have cosine of pi over 6. This is going to be equals to the difference of the y coordinate. So that's going to be 4 minus y. Divided by, we'll take sine of the angle that the line L makes with the x-axis. So that's also pi over 6. And this is going to be equals to AB. So AB is the length that we need to obtain here. Let's further simplify. So we have 3 minus x divided by, so cosine of pi over 6 radians, that's going to be square root of 3 over 2. And then we have 4 minus y divided by sine pi over 6 radians, so that corresponds to 1/2. That is going to be equals to AB. So we can have two equations. And one of the equation is 3 minus x divided by square root of 3 over 2. This is going to be equals to AB. And we have 4 minus y divided by 1/2, and that is also going to be equals to AB. Now from this equation, these two equations, we can isolate x and y. So x becomes equivalent to, we have 3 minus AB times square root of 3 over 2. And y becomes equivalent to 4 minus AB over 2. So here what we have done, we have considered the point B, and we have successfully expressed x and y in terms of the parametric form. So here AB is going to be the parameter. So we can say that the coordinates of the point B, coordinates of B are, so they are going to be, we have 3 minus square root of 3 times AB over 2. And then we have 4 minus AB over 2. Fine. Okay, now that we have the coordinates of point B, we can make use of the fact that since that point B is going to lie on the line L prime has the equation 12x plus 5y plus 10 equals to 0. So we can replace x and y with the x and the y coordinate of point B, and that is going to help us determine the value of AB. So let's do that. We have 12 multiplied to x. So x is going to get replaced with 3 minus square root of 3 times AB divided by 2. Added to 5 times y, so y here is 4 minus AB over 2. Added to 10, so that is going to be equals to 0. So this means we now have 12 times 3, that's 36. 36 minus, we have 24, this is going to be 6 times square root of 3 times AB. Added to 5 times 4, that's 20, minus 5 over 2 times AB. Added to 10. That's going to be equals to 0. Right? So we have now negative 6 times square root of 3 and negative 5 over 2. So that's going to give us 12 times square root of 3 plus 5 whole divided by 2 multiplied to AB, and that is going to be equal to 66. Fine. Now let's solve for the value of AB. So AB comes out to be equals to 132 divided by 5 added to 12 times square root of 3. So this is going to be the length of AB.